Hi everyone, welcome back to our channel. As you know, we are trying our best to cover all technical topics related to Azure. Don't forget to subscribe our channel and stay tuned for more updates. So let's start today's topic. So in today's video, we will discuss possible reasons of the AKS pod crash. There are several reasons why AKS pods may crash. We will discuss about a few of them. So let's start one step by step. So let's say the first one, application level issue. So when we say application level issue, mostly root cause is always related to the application inside the container may have bug, or it may have some misconfiguration, or might be some dependencies are getting failed. So for an example, unhandled exception in the code, dependency libraries are missing, misconfigured application environment variable. So these are the three examples which can cause the application level issue. So as a solution, what we can do, we can check the application log using kubectl logs command. You can put like kubectl logs and then you can enter the pod name, and once you use this command you will get the logs, and from that logs you can identify the issue. Another way to you can debug and redeploy the application with the fix. So you can make that application level changes, and then you can redeploy that image, or you can redeploy that application. Second option is a resource constraint. So root cause of this is insufficient resource like a CPU or memory allocated to the pod. For an example, pod get evicted due to the lack of memory. Pod enters a crash loop because it run out of resources. So these are two example of this resource constraint. Now solution is we can check the resource usage with the kubectl top pod command and kubectl top node command. We can update pod resource request and limit in the YAML file, and we can update the deployment. Similar way, we can scale up the AKS cluster. We can add more. We can add node pool if resources are insufficient. Now let's talk about crash loop back. Crash loop back means container keeps restarting due to an error in initializing or execution. So that is the main root cause. Invalid startup command, that also could be one reason. Another like missing files or directories in the container. So as a solution, same way you can check the pod logs with the kubectl command like kubectl logs. Also you can validate some event details with the kubectl describe pod, and you can you can use this command like kubectl describe pod, and you can enter the pod name, and from that you can check the events for that specific pod. Also you can validate and fix the startup command or configuration. Now let's talk about image issue. Third, the root cause of image issue is like problem with the container image used in the pod. Let's say incorrect image version or tag specified. Let's say you want to use image v 1.0, but somehow you updated the version something called 001 something. So that could be also one of the issue. Another is pool error due to authentication issue with the container registry. So as a solution, we can make sure that we are using correct image, and that image should be specified in a deployment YAML clearly. Also we can verify image availability in a container registry to avoid these image issues. Third is we can test the image locally using docker pull or similar kind of commands. Now networking issues. So this is also one of the main cause. So root cause, network misconfiguration or policy blocking communication. Example, DNS resolution issues, pods unable to connect to service or external endpoints. So these two are example. As a solution, You can check pod network status using kubectl get pod -0 wide of kube. You can check proper configuration of Kubernetes network policies and DNS setting. You can test the image, I mean same week you can test the image locally using Docker pull and other similar command, and you can check the networking, I mean DNS related issue as well. Now node level issues. So no, for node level issues, root cause always problem with AKS node hosting the pods. Example, node out of resource issues, node becoming not ready. So these two examples of this issue. As a solution, we can check node status with kubectl get node. Also, we can check node details with kubectl describe node, and we can address if there is a issue with specific, like scale the cluster, or you can replace the faulty nodes as well. Now let's talk about config map or secret issue. So root cause of config map and secret issue: misconfigured config map or secret reference by the pod. For example, you missing the config map and secret in a pod, or else you incorrectly mounted volumes. The solution: you can verify the config map and secret using kubectl get config map and kubectl get secrets. Also, you can check pod YAML to proper mounting. Now, persistent volume issues. So, root cause of persistent volume issues: problems with volume mount or storage claim. Example, PVC not bound to a PV. Second, incorrect volume path in the pod. As a solution, we can check PVC and PV status with kubectl get PVC and kubectl get PV. You can fix storage class or volume configuration. Now, liveness readiness probe failures. So root cause for this is misconfigured or failing health check. Example, liveness probe keeps failing and restarting the container. Second, readiness probe failure prevent the pod from serving traffic. Solution: we can you can review the probe configuration in the deployment YAML. Use proper endpoint or commands for probes. Cluster autoscaler and scaling issues. So root cause for this is scaling issues due to cluster autoscaler configuration or resource contention. For example, pods pending due to insufficient nodes. So as a solution, enable cluster autoscaler if not enable. Also, you can manually add node pools and increase the node count as well. So far we have seen 10 number of pod crash reasons. Yeah, that's it for today's video. If you found this video helpful, please don't forget to share and subscribe our channel. Thanks for watching.